Millennia ago, China forever changed the world map with the Great Wall. Today, that massive ambition is back on a planetary scale that feels like it's ripped straight from cutting-edge sci-fi. We're talking about megaprojects so huge, they're literally reshaping the Earth's geography. Bridges vanishing into the clouds at impossible heights and entire cities packed into a single gigantic building. Infrastructure that defies gravity and logic. Join us on this mind-blowing journey through the engineering of the future that's redefining what's possible and pushing the boundaries of what's achievable. But before we dive into this epic tour of limitless human ambition, if you're hooked on extreme engineering and megaprojects, hit that like button and subscribe to the channel so you don't miss any of our tech explorations. And tell us in the comments below, do you think human ingenuity has any real limits? Or will we keep surpassing ourselves forever? All right, let's kick off the countdown of these giants. Number 10, the Great Wall of China. You probably think you know this world-famous icon, visited by millions inside and out. But to really grasp the scale of modern Chinese engineering, we have to go back to the very roots of millennia-old human ambition. We're not mentioning the Great Wall as just some ancient archaeological relic from the distant past, but as the direct genetic ancestor of all the megaprojects you'll see in this stunning video. According to the latest mapping and archaeological data from China's National Cultural Heritage Administration, this massive defensive system stretches a total length of 21,196 kilometers. To put that in perspective, that's like crossing the United States coast to coast nearly 7 times, or halfway around the Earth's equator. But this astronomical figure isn't just a line on a map. It's a massive alteration of the continental landscape carried out over 2 full millennia of continuous, uninterrupted construction by generations. The scientific genius of this structure lies in its primitive yet revolutionary materials, science for the ancient era. The dynasty's engineers developed a biological mortar made from slaked lime and sticky rice. Thus, the amylopectin in the rice created a molecular structure so dense that even today it prevents vegetation from growing between the bricks. And it withstands earthquakes that would topple modern reinforced concrete structures. This is solid proof that engineering in this region isn't measured in decades, but in entire eras of civilization. But there are more fascinating details that few people really know. Building the Great Wall required mobilizing millions of workers across entire generations of families. It's estimated that over 1 million people died during its prolonged construction. The logistics were astonishing without any modern technology. Materials had to be transported across rugged mountains and inhospitable deserts. No modern machinery, no trucks, no advanced hydraulic cranes. Everything by human hands or basic pack animals. Some sections of the wall are in spots so remote that even today they're hard to reach with modern vehicles. The Great Wall was the first planetary-scale experiment in advanced logistics and structural resilience, setting a historical precedent for determination. If the terrain is hostile, the infrastructure must be absolute and unbreakable. This same determination to conquer hostile nature is what has led modern cities to seek a balance between massive concrete and biological life. Number 9. Forest Garden City in Chengdu. In the metropolis of Chengdu, home to over 20 million densely packed people, engineering has stopped fighting nature and instead integrated it into an unprecedented vertical symbiosis. The Chiyi City Forest Garden Complex represents a direct evolution of sustainable urban development, specifically designed to combat the urban heat island effect plaguing millions of residents breathing polluted air. And this mega-project consists of 8 residential towers where architecture becomes a fully integrated, active, and functional ecosystem. Unlike a conventional horizontal garden, every balcony on these structures has been meticulously designed to handle specific hydrostatic and mechanical loads, allowing the controlled growth of over 20 plant species scientifically selected for their carbon absorption and high-altitude wind resistance. From a complex technical viewpoint, and the main challenge was structural integrity against deep root infiltration and the weight of water-saturated soil after heavy rains. Engineers implemented high-density, molecular polymeric waterproofing layers and multi-layer drainage systems integrated directly into the reinforced concrete. An automated irrigation system, managed by precision algorithms, delivers the exact amount of water and nutrients needed, optimizing scarce urban water resources. And this project isn't just aesthetic for Instagram pics. It's a massive air filtration station that produces clean oxygen and reduces ambient noise for thousands of densely populated residents. Each year, these green towers absorb 25 tons of harmful carbon dioxide, and they produce 60 kilograms of oxygen daily for the city. It's the scientific answer to China's extreme urban population density. If there's no room for forests on the overcrowded ground, we'll build them skyward vertically, using that same verticality that's now letting humans move at speeds that challenge known physics. Number 8. 600 kilometers per hour maglev train. If the Great Wall defined territorial boundaries, the new magnetic levitation, or maglev train, is erasing the barrier of time with a steady operating speed of 600 kilometers per hour. This ground transportation system is currently the fastest on the entire planet, sitting right at the critical threshold between conventional, high-speed rail and commercial aviation. The science behind this megaproject is based on total elimination of physical contact using powerful superconducting electromagnets that are cooled. The train levitates over a guideway at a constant distance of 10 to 15 millimeters, completely nullifying the mechanical friction that limits traditional wheeled trains. Technical analysis shows superior energy efficiency, because power is used almost exclusively to overcome aerodynamic drag, and acceleration, not to fight track friction. Propulsion is achieved through a synchronous linear motor that uses electromagnetic waves to push the train with absolute millimeter precision. Plus, integration with the Beidou satellite system enables autonomous traffic control with reaction times impossible for a human operator. But this project doesn't just redefine national logistics by connecting major economic hubs in fractions of time. It represents absolute mastery over magnetism to move hundreds of tons of mass, with the elegance of a subatomic particle. It's the final step before architecture decides to literally float above the Earth without contact. Passengers report the ride is extraordinarily smooth. At 600 kilometers per hour, you can stand a coin on its edge and it stays upright. That's perfect stability. Number 7. Tianjin Binhai Library. If knowledge is the foundation of modern civilization, this structure is its cathedral of crystal and natural light. Located in the Binhai Cultural District, this library isn't just a repository for old books. It's a masterpiece of computational architecture, spanning 33,700 square meters. The design revolves around a luminous spherical auditorium, nicknamed the Eye, that seems to observe society's development through its transparent glass facade. And the most disruptive feature of this space is its cascading shelving structure that waves from floor to high ceiling, creating an interior topography that functions simultaneously as seating, stairs, and shelves. From a spatial engineering viewpoint, the fluid curves were calculated using advanced algorithms to maximize natural light diffusion and optimize internal acoustics. Though it looks like a dreamlike environment visually, its construction required rigorous structural precision to support the weight of 1.2 million volumes. The upper levels, physically inaccessible but visually integrated via printed aluminum plates, serve as a metaphorical reminder of the infinity of human knowledge. This megaproject shows how contemporary architecture can use parametric design to transform a functional space into a hub for social and cultural interaction. That challenges traditional orthogonal geometry conventions, and it's literally knowledge made into physical architecture. The library can accommodate up to 1,200 people at once, and it's become an architectural icon, Visited by millions since its opening, it's proof that functionality and art can coexist perfectly. Number 6. Huangjuewan Interchange in Chongqing. In the megacity of Chongqing, where mountainous geography severely limits horizontal urban development, engineering has responded with the planet's most sophisticated highway complex. The Huangjuewan Interchange is a three-dimensional maze of 5 levels integrating 20 intertwined ramps in 8 different directions. This logistical node is the scientific solution to rugged topography that prevents horizontal expansion, forcing engineers to layer traffic flow in a multi-level structure that seems to defy conventional navigation logic. The technical complexity of Huangjuewan lies in spatial planning using 4th-generation BIM models that allowed coordinating each ramp's construction without disrupting lower layers' flow. Engineers had to calculate turning radii and slopes precisely for heavy cargo vehicles at extremely tight angles, maintaining structural integrity against constant vibrations. Despite its reputation as a challenge for current GPS navigation systems, this interchange is an urban efficiency marvel, allowing thousands of vehicles to transit daily between central districts and industrial zones without collapsing the city's fabric. It's the circulatory system of a metropolis that's decided to grow upward and inward, overcoming natural obstacles with pure mathematical ingenuity and determination. Some drivers report that using GPS here is useless. You have to know the routes by heart. But for local residents, it's just part of daily life in one of the world's most vertical cities. Number 5. Beipanjiang Bridge. Soaring at a dizzying height of 565 meters above the Niju River Canyon, the Beipanjiang Bridge holds the official title of the world's highest structure of its kind right now. This civil engineering feat connects the provinces of Yunnan and Guizhou, regions historically isolated by impassable chasms. The 1,341-meter-long bridge is a cable-stayed system that must withstand not only massive vehicle loads but also extreme aerodynamic forces from winds channeled through the gorge. Building this mega-project required millimeter precision under hostile atmospheric conditions. Engineers used fiber optic sensors and real-time monitoring systems to assess cable tension and main tower oscillation during the central span closure process. Due to the valley's depth, conventional scaffolding was impossible. So they employed successive cantilever techniques with high-capacity cranes, operating hundreds of meters above the rocky ground. This bridge has drastically cut travel times, turning a 4-hour journey on winding roads into a straight 60-minute trip. It represents the triumph of structural science over the abyss, proving no physical barriers insurmountable when tension calculations and human determination are applied. To put the height in perspective, the bridge is 565 meters above the river, and the Eiffel Tower is 300 meters tall. This bridge is almost twice as high as Paris's most iconic monument. Number 4. Intercontinental Shanghai Wonderland Hotel. This mega-project is an absolute break from conventional architecture, as the world's first hotel built inside an abandoned quarry. Descending 88 meters below ground level, known as inverted architecture, this bifid hotel integrates directly into the rock walls of an old mine, transforming an industrial scar into a model of sustainability and radical design. Of its 18 total floors, 16 are below surface level, including 2 fully submerged levels underwater, in a 10-meter-deep artificial aquarium with fish. From a geological engineering perspective, the challenge was monumental. Specific solutions were needed to prevent rock wall instability and manage the quarry's natural water flow. The structure uses the Earth's thermal mass to regulate internal temperature. It is supported by a geothermal energy system that significantly reduces the complex's carbon footprint. This project isn't just a luxury retreat. It's a lesson in architectural healing that shows degraded industrial spaces can be transformed. The hotel has rooms with underwater views where you can see fish swimming by. It's a surreal experience sleeping 88 meters underground, but feeling connected to nature. Number 3. East Fusion Reactor. In the Hefei labs, the science is trying to harness the power of stars to solve the global energy crisis. The East Reactor is a tokamak-type nuclear fusion device aiming to replicate the hydrogen fusion process at the Sun's core. The latest data confirms impressive historical milestones. The reactor has sustained plasma at 120 million degrees Celsius for over 100 consecutive seconds. That's 10 times hotter than the actual Sun's core. The scientific foundation of this megaproject is advanced magnetic confinement. Since no solid material can withstand such extreme temperatures, the plasma is suspended in an absolute vacuum via ultra-powerful magnetic fields generated by superconducting magnets cooled to near absolute zero. The ultimate goal is clean, safe, and practically inexhaustible fusion energy, without the long-lasting waste of conventional nuclear fission. This project puts China at the forefront of particle physics and thermonuclear engineering. If they master fusion, it would be the holy grail of energy. Unlimited fuel from seawater, no pollution, no radioactive waste. It would be the ultimate solution to the energy crisis. Number 2. Zhangjiajie Glass Bridge. Located in the stunning natural park that inspired sci-fi movie landscapes, the Zhangjiajie Glass Bridge is a feat of materials science. With 430 meters in length and suspended 300 meters over a deep canyon, this structure uses 3-layer laminated glass panels that are resistant, each 5 centimeters thick, designed to be structurally redundant. To validate safety, extreme impact and static load tests were performed. Technically, the bridge's biggest challenge isn't weight, but the wind blowing through the canyon. To counter oscillations, engineers installed over 70 tuned mass dampers. These devices absorb vibration energy from both wind and synchronized visitor footsteps, keeping the structure stable. Walking on this bridge is a terrifying experience, but you can see straight down 300 meters through the glass. Some people freeze from fear, but it's completely safe structurally. Number 1. If ancient history built walls to defend territories, modern engineering decided to master a much more unpredictable force: water. The Three Gorges Dam isn't just the planet's largest hydroelectric plant. It's a continental-scale human intervention. It spans over 2,300 meters across the Yangtze River and reaches 185 meters in height. Its reservoir stores nearly 39 billion cubic meters of water, a mass so colossal that, according to scientific studies, it has minimally altered Earth's rotation by fractions of a microsecond. Its capacity exceeds 22,500 megawatts, enough to power millions of homes and entire industries. But its function goes beyond generating energy. For centuries, the Yangtze caused devastating floods. Today, this megastructure regulates its flow, protects cities, and turns an unpredictable river into a controlled artery. Construction required over 27 million cubic meters of concrete. Giant turbines, monumental gates, and a lock system were installed to allow large tonnage vessels to pass. Its impact was huge. Over 1 million people were relocated, and entire regions were submerged to make way for the reservoir. Mountains pierced, valleys flooded, a redesigned landscape. It's not just infrastructure, and it's proof that humanity can contain natural forces that for millennia seemed untamable. Thanks for joining us on this epic journey through the limits of human ingenuity and determination. Of all these monumental giants we've broken down in detail, which one has totally shifted your perspective on humanity's future? Leave your honest opinion in the comments, because we love reading what our passionate subscribers think. Each of these projects represents decades of planning. There are thousands of engineers at work and billions of dollars invested. These megaprojects aren't just structures of concrete and steel. They're statements of intent. They're proof that humanity can solve its biggest problems with engineering and science. If you've been fascinated by this in-depth look at extreme engineering, Don't forget to like and subscribe to the channel to keep exploring the frontiers of our planet and beyond together. Until our next tech adventure, where we'll keep uncovering the extraordinary.